Okay, so here we are at the ventilation system at the Corona house. With any passive house, ventilation is extremely critical. The way that we get to a very airtight and low energy building is by reducing air infiltration all throughout. So because of that, we need to introduce fresh air to make sure that the air quality is really excellent. And in fact, most homes don't have any way of introducing fresh air, so even though we have a tight home here, it's actually much improved air quality over a standard home. So the way that this guy works is that these insulated lines that you see here are bringing air in from the outside and exhausting stale air. So fresh air comes in and then travels through the heat exchanger and then into the building through this duct above. Stale air comes out through this duct and then goes out through that other duct. As they pass each other, the warm air from inside the house gets recycled back into the fresh air without the air streams actually mixing. So we have fresh air that's preheated and stale air that goes out. It's so efficient in this model that over 90% of the heat that is going out of the building gets recovered back into the incoming airstream. So even if it's really cold outside, you're not dumping in cold air from the outside. There's really almost no difference in the air temperature coming in as there was going out, only a few degrees difference. This is also extremely energy efficient, uses a little more than a couple light bulbs worth of electricity, and it's actually very, very quiet. Right now we have it on full blast and it's barely audible. So this is an extremely quiet, fresh air system for a passive house. Great, so here we are at the outside of the Corona house. And right here in my hand is the entire heating system for the whole building. This heats all of the domestic hot water and all of the heat for the entire facility. And it's really impressive at how small it is. Again, it's drawing on the outside air to move that heat from out here into that box we saw inside down in the mechanical room, which is right behind me. So again, the reasons that we chose this unit is inverter controlled. And what that basically means is it's variable. The colder it is outside, the more it can ramp up. And when it's warmer like it is right now, it can go down and operate at really, really high efficiency levels. So a ground source heat pump would require much more hardware. It would require hundreds of feet of loop pipe in the ground. But with this, all we have is this single, simple outdoor unit. So a really efficient system to provide heating and hot water for this house.